All right, hello everybody and welcome. I'm going to call this Kitchen Chemistry with Miss Rickman. And maybe if I figure out how to edit, we can put some music in here. If not, then maybe somebody else can do it for me. So before the spring break and then the quarantine happened, I was on chemical reactions with my students, and my physical science students in the past learned about density. So I thought of an experiment that we could do at home in our kitchens, and it needs just a couple materials. Let me show you what those are. Vegetable oil is what I'm going to be using, but any type of oil should be okay. And then effervescent tablets, so your Alka-Seltzers. I'm using like teeth cleaning tablets. And then a water bottle with about 20% of the water left in it. And then food coloring. If you don't have food coloring like me, you can use drink powder. Okay. So let's talk about the science behind this experiment. This experiment is making an at-home lava lamp. The science behind it, what makes it work is, the first thing, density. The two liquids that we're using are oil and water. Oil is less dense than water, so it's going to float on top of the water. Now, to get the lava lamp effect, we're going to add some color. That's what the drink powder or food coloring will do. So add some color, and then what gets the water to rise up and then fall back down, like we see in your classic lava lamp, is this effervescent tablet. How I'm tying this into what my kids are learning about chemical reactions is this tablet right here. This tablet is made of an acid and any type of metal carbonate, which I think these ones are calcium carbonate. And when an acid reacts with a carbonate, it always produces three products. It produces salt, it produces water, and it produces carbon dioxide gas. That carbon dioxide gas is what we need to make our lava lamps work. So when we put the effervescent tablet into the water, it produces salt and water, which that's great, but we can't really utilize those. We can utilize carbon dioxide. That carbon dioxide will help in lifting up the water through the oil. And then once it gets to the top here, the carbon dioxide will escape, leaving the water to drop. It'd be really cool. So let's get started. All right, so I'm gonna grab my drink powder. This stuff is cherry pomegranate, and it's delicious, but it's this really deep red color, which makes it look pretty cool. So there I have my red color. I'm gonna have a red lava lamp. I'm super excited about it. I think I'm gonna split it in my office. Then I'm gonna add oil to the bottle of water here. I'm gonna add it to about this line right there. Okay, so I went over to the sink and I added the oil. Looks like this. If we give it a little bit of time, you'll have complete separation there. So the next thing that you guys want to do, I like to use 2 effervescent tablets. I'm going to break them up just a little bit so that they fit through this hole. And I'm going to add them. And one of the materials that I actually forgot to tell you about, which makes this look really cool, is a flashlight. So I've added my effervescent tablets. They drop down to the water there, and you can see them start to bubble. All right, so I'm gonna take this to my bathroom and shine the light underneath it. Okay, everybody, so I've made it to my bathroom, and the reason I tell you to go to your bathroom is because you can make it really dark in here. So notice the periodic table shower curtain. It's a necessity for our science teachers. So I'm going to turn off the light, and then I'm going to put my light underneath my lava lamp. Okay, just like that, and it makes it look really cool. Ooh, lava lamp. I feel that the camera is not doing justice to how cool this looks. This is awesome. Okay, so As always, if you need my help, I am always available for you. You can email me. You can join my office hours on Google Meets, and I will be available to help you with this. Take care, everybody. Stay safe.